We're going to cover some basic rules of logarithms. We're looking at first evaluating logs without a calculator. And one of the things we want to start off remembering and realizing is that your basic rule of thumb is that logs give you exponents. Please remember that as we begin. So our first problem has log base 5 of 25. Remember, we're looking for exponents. So the best way to do this is to rewrite 25 as a power of 5. We know 25 is simply 5 squared. So this is log base 5 of 5 squared. Remember, your rule is that logs give you exponents, so the exponent would be 2. We've matched our base for our log and the base for the way this is written as an exponent. So log base 5 of 5 squared is 2. Our next example, same concept, log base 3 of 81. 81 is just 3 to the 4th power. So again, log base 3 of 3 to the 4th is 4. Here we get into a little bit trickier example. This is log base 3 of 1 over 27. Well, 27 we know is a power of 3. It's 3 cubed. But since it's in the denominator, I need to account for that, and that means that log base 3 of 1 over 27 is log base 3 of 3 to the negative 3 power, so my answer is negative 3. And my last example is log base 6 of root 6. Again, we need to account for the square root of 6. Well, the square root of 6 is just 6 to the 1/2 power. So log base 6 of 6 to the 1/2 is 1/2. Again, all we're trying to do is simplify logs. Let's look at changing forms with logarithms. We have two forms we can write things in, either in a logarithmic form or in an exponential form. In a logarithmic form, we have y equals log base b of x. Again, I told you logs give you exponents. So if I rewrote this, my base is b, my exponent is y, and that is equal to my x. So b to the y equals x. Well, how does this help us? We have three types of problems we'll be able to looking at. The first is 2 equals log base 5 of x. Well, here the x is inside the logarithm. I want to solve for x. So what I need to do is I need to go from logarithmic form to exponential form. Again, my base is 5. My exponent is 2 because logs give me exponents. So this is 5 squared equals x. So x is 25, and I've already solved this. The next example is 3 equals log base b of 64. In this case, you don't know the base, but you know the exponent and the stuff inside the log. b is your base, 3 is your exponent, so b cubed equals 64. You take the cube root of both sides and you get b is 4. Your next example is y equals log base 3 of 7. We're not going to cover this one quite yet. This is something we'll learn later on. But please note the difference between the three. They're all basically the same type of equation. On the 2 on your left, the variable is inside the log, so you need to switch from log form to exponent form. There's a couple of properties of logs we want to look at. There's what's called our inverse properties. Logs and exponents basically undo each other. So log base b of b to the x, we saw this before, where we're trying to find the exponent. Log base b of b to the x is simply x. And b to the log base b of x power is x. So the base and the log, if they're the same, they undo each other, and all you wind up with is the exponent. So here I have log base 4 of 4 to the 5th. The bases both are here, they undo each other, and I wind up with 5. Similarly, 6 to the log base 6 of 9 power. The base in the log is the same as the base here, so they kind of undo each other, and I simply wind up with 9. The last two things we want to look at are the properties of logs. These are some common properties. Log base b of 1 equals 0, and that should make sense. That should make sense because I'm looking for an exponent. So b to the what power is 1? Well, b to the 0 power is 1. Therefore, log base b of 1 is 0. Similarly, log base b of b is 1. Again, logs give you exponents. b to the what power is b to the first power. So log base 4 of 4 is 1. Log base 5 of 1 is 0. Look over these properties, work with them. I think you'll find them to be very helpful as you solve the problems in this section.